Hey guys, welcome back to another Mathin' with Coach Lynn. Today we're going to cover lesson 4.3, compare and order integers. This begins on page 213 in your Tennessee Reveal math book. The I can statement states I can correctly order rational numbers, including integers and absolute values, and then use a number line to write a statement of inequality. Now let's take a second to have a reminder of what integers are. Integers are any number that is positive or negative, but it must be a whole number. No decimal, no fraction. Now let's look at the Learn section. It says compare integers. To compare integers, you can compare the signs as well as the magnitude or size of the numbers. If the signs are different, the positive integer will always be greater than the negative integer. So we see an example with different signs. Compare 2 and -3. The signs are different, so compare the signs. A positive integer is always greater than a negative integer, so 2 is greater than -3. We express that in an inequality shown here. 2 is greater than -3. We know this is the greater than symbol because the mouth is eating the larger number. If the signs of the two integers are the same, you can use a number line to compare them. On a horizontal number line, positive integers are graphed to the right of 0, while negative integers are graphed to the left of 0. The greater numbers will be farther to the right. On a vertical number line, positive integers are graphed above 0, while negative integers are graphed below 0. The greater numbers are graphed farther above 0. So we're comparing integers with same signs, -2 and -3. The signs are the same, so we'll use a number line to compare the integers. Because -2 is graphed farther to the right than -3, -2 is greater than -3. So as they said above, numbers further to the right are greater than numbers that are farther to the left. We can also remember that numbers to the left of 0 are negative. Numbers to the right of 0 are positive. One simple trick I like to remember about which one's less and which one's greater is less and left both start with the letter L. Now let's look at example 1. Compare two integers. Justin has a score of -5 on the Trueville trivia game. Desiree's score is -3. Write an inequality to compare the scores. Then explain the meaning of the inequality. Part A. Write an inequality. Graph the integers on a number line. So we're going to take our two numbers we have from our situation and graph them on a number line. Justin's score was -5. So we'll put a dot on -5. And Desiree's score is -3. So we'll put a dot at -3. Now we're going to compare the numbers. We know numbers farther to the right are the greater number. So we can see out of our two that -3 is our greater number. So the inequality to write this would be -3 is greater than -5. Part B, explain the meaning of the inequality. Since -3 is greater than -5, Desiree has a greater score in the trivia game. Now let's look at our check problem. Andrew and his father are hiking near Tacklebox Canyon. Their current elevation in relation to sea level is -38 feet. Tacklebox Canyon has an elevation of -83 feet. Write an inequality to compare the elevations. Well, we know their current elevation is -38 feet. And the canyon is -83 feet. If we were to graph this on a number line, -38 would be farther to the right than -83, so we know -38 is greater than -83. So I'm going to write -38 is greater than -83. Again, using my greater than symbol. The mouth is eating the larger number. We know -83 is the larger, the greater number, because it's further to the right on a number line. To explain the meaning of the inequality, like we said, since we know that negative 38 is greater than negative 83, it is a greater elevation, so it is higher up than Tackle Box Canyon, which is at negative 83 feet. It would be lower in elevation compared to sea level. Now let's learn to order sets of integers on page 215. You can use a number line to order a set of integers from least to greatest or from greatest to least. The animation shows how to graph the set of integers negative 8, 3, negative 1, 0, 6 on a number line. From left to right, the integers are from least to greatest, or negative 8, negative 1, 0, 3, and 6. From right to left, the integers are from greatest to least, 6, 3, 0, negative 1, and negative 8. Now example 2, order sets of integers. The table shows the lowest accessible elevations for several continents. We have Antarctica at negative 50, Australia at negative 15, North America negative 86, and South America at negative 105. These are all their elevations in meters. So we're going to order the continents from least to greatest according to their lowest elevation. First thing we're going to do is graph them on the number line. We got negative 105, negative 86, negative 50, and negative 15. So which continent has the least accessible elevation? Well, we know the least is always to the left because least and left both start with a L. So negative 105 is our least, and that goes with South America. Which continent has the greatest accessible elevation? Well, we know the greatest is going to be opposite of the least. So if the least is to the left, the greatest will be to the right. That's going to be negative 15, which goes with Australia. So the continents written in order from least to greatest elevations are South America, North America, Antarctica, and Australia. Now let's look at the check problem on the next page. The table shows Keisha's cell phone use over the last 4 months. Positive values indicate the number of minutes she had remaining, and negative values indicate the number of minutes she went over. Arrange the months from fewest to most minutes remaining at the end of each month. So to do this, we can set up a number line. Draw my line. I know I've got negative 156, 12, 0, and 45. So I'm going to start with 0. Put it right about here since I have a little bit of a positive number at 12. And I'm going to go in increments of 10. So I'm going to put a line here for 10. Then I'm going to work my way back. I'm going to do 10, 20, 30, 40, 50, 60, 70, 80. I'm going to have to make my line longer. 90, 100, 110, 120, 130, 140, 150, and 160. So I'm going to need to go a little bit past negative 156. So I'll go to negative 160 to graph my months. So we know April is at 0. Put an A above it for April. March is at 12, so it's going to be a little past 10. We'll put an M there for March. And then May is at negative 45, so we're going to go 10, 20, 30, 40, 50. But we know 45 is between 40 and 50. So we'll go ahead and write May there. And then negative 156, so we know that was 45, that's 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. Then we have 160, so that number's about in the middle of those two at negative 156. which is February. So now we've arranged them in order, and now we can write them from fewest to most minutes remaining as they asked us. So we know it's going to be February, and then May, April, and then last would be March with the most minutes remaining. On page 217, we have a Learn section where we're going to distinguish absolute value from order. We know the order numbers, when you see them in a horizontal number line, the values increase as they move to the right, and the values decrease as they move to the left. So when we have absolute value or magnitude, do the values increase or decrease? Since absolute value is the distance a number is from zero, the absolute value increases the farther we get from zero. So as the positive number increases and moves farther towards the right, the higher its absolute value will be. As a negative number moves farther to the left away from zero and becomes a higher negative number, the greater its absolute value becomes. So suppose Cato and Ember are scuba diving. Cato dove to 25 feet below sea level. This can be represented by the integer negative 25, because sea level we know is 0, and if you dove 25 feet below that, that would be negative 25. Ember dove to 30 feet below sea level. This can be represented by the integer negative 30. The same reasoning. So who reached a greater depth? You know that negative 25 is a greater number than negative 30, but that does not mean that Cato's depth was greater. When determining who reached a greater depth, we had to consider the magnitude of the numbers, not just where they belong on a number line. The absolute value of a number takes into account the number's magnitude, because absolute value is the distance from zero, and in this case, 0 is sea level, and we want to know how far they dove and who dove the greater distance. So the absolute value of negative 30, we know is 30 because it is 30 units from 0. The absolute value of negative 25 is 25 because it is 25 units from 0. So which absolute value is greater? Well, negative 30's absolute value is greater, since the absolute value of negative 30 is 30, and the absolute value of negative 25 is 25. So the absolute value of negative 30 is greater than the absolute value of negative 25. So Ember's depth is greater. Now let's look at example 3 on page 218 and compare with absolute values. Explain why an account balance less than negative 40 represents a debt greater than $40. Debt is the money owed by one person to another person. An example of an account balance less than negative 40 is negative 50. Write an inequality comparing the two amounts. So we know negative 50 is less than negative 40, because on a number line, negative 40 would be closer to 0 and more to the right than negative 50. If we use absolute value to determine which integer represents a greater debt, we know the absolute value of negative 50 is 50, because the distance from 0 and absolute value is always a positive number, and the absolute value of negative 40 would be 40. So now we're comparing 50 to 40, and we know 50 is a greater number than 40. So an account balance less than negative 50 has a lesser value, but a greater absolute value. So an account balance of negative 50 means the debt of $50, which is greater than a debt of $40. Now let's look at the check. Explain why an account balance less than negative 5 represents a debt greater than $5. So like we did in the example, if someone owes negative 5 in debt, and we have another account with a balance of less than that, which we know negative 10 is less than negative 5 because it is further away from 0 in the left, in the negative direction. Now we compare them with absolute values. Someone with a negative 5 account would be $5 in debt, and someone with a negative 10 account would be $10 in debt. We know $10 is greater than $5, so they are in more debt than the person that is a negative $5 account balance. So this has less value than the negative $5 account. Now let's bring comparing and ordering integers to the real world with our apply problem on page 219. The table shows the freezing points in degrees Celsius for 6 substances. Nitric acid freezes at negative 42 degrees Celsius. Between the freezing points of which 2 substances is the freezing point of nitric acid? So we have a list of substances here and their freezing points in degrees Celsius. We want to know where nitric acid would fall in that substance list. Well, we would need to order them from least to greatest, or from greatest to least, just one way or the other, so we know an order and where nitric acid would fall in that list. So I'm going to order it from least to greatest. Well, I know numbers that are less are more to the left on a number line, and they are further away to the left from 0. They may have a larger number of more magnitude, but the negative sign makes them lesser in value. So I'm going to find the biggest number with a negative symbol, and in this case it is negative 95, which is acetone. So I'm going to put acetone at the top of my list with negative 95. I'm going to cross that off. Now I'm going to look at the next highest magnitude number with the negative symbol, and I see negative 78. So I'm going to cross that off and write carbon dioxide with negative 78. And so I'm going to look at my next number with the highest magnitude that has a negative symbol. I have 2 negative numbers left. 6 is greater than 2, but it has a negative symbol, so I know it's a lesser value. So aniline is next with a negative 6 degrees Celsius freezing point. So that leaves me with seawater at negative 2 degrees Celsius. Now I'm going to look at the 2 I have remaining. I have water with a 0 degrees Celsius freezing point and acetic acid with a 17 degrees Celsius freezing point. We know 17 is greater than 0, and 0 is right where has a no value of positive or negative, but it's where we transition from positive to negative numbers, so it will be right between any set of numbers. We have positive and negative values. So water will be next with 0, followed by acetic acid with 17. So now I need to know where nitric acid would fall if it was negative 42. So I'm going to have to look at my magnitude of my values in the negative area. So I have negative 95, negative 78, negative 6, and 2. And I know that 42 would fall between 6 and 78. So if I were to add nitric acid to this list, it would fall right here between carbon dioxide and aniline. Now let's work a couple problems together on page 221 on our practice page. Number 1, after playing 18 holes of golf, John's score was -4 and Terry's score was -1. Write an inequality to compare the scores, then explain the meaning of the inequality. So we have John's score at -4 and Terry's score at -1. We know 4 has a higher magnitude than 1. If they were both positive, 4 would be our greater number. But so they're both negative, so the higher magnitude number is a lesser value. So we know John's score is less than Terry's score. So we know -1 is greater than -4. This means that Terry had a higher score than John. Now let's look at number 3. The table shows the freezing points for gases. Order the gases from least to greatest according to their freezing points. Argon, -189. Carbon monoxide, -205. Ethane, -297. Helium, -272. Oxygen, -219. And sulfur dioxide, -72. Now all these numbers, if we look, have a freezing point in the negative degrees Celsius. So this helps us out, but we know the number with the highest magnitude will be the lesser value. So we just need to find the number that is the highest, and it will be our least valuable number, and it will go first in our order from least to greatest. So I look here, I see 297. So ethane will be first. Next, 272, helium. Next, I have a 219 and 205. We know 219 is higher than 205, but with it being a negative, it has a lesser value, so it'll be next, and that is oxygen. So then carbon monoxide with -205. That leaves us with argon at -189 and sulfur dioxide at -72. Well, argon has a much greater magnitude at 189 than 72, where the negative symbol makes it lesser in value. So we know argon will be next, followed by sulfur dioxide. So ethane, helium, oxygen, carbon monoxide, argon, and sulfur dioxide in order from least to greatest based off of their freezing points. So let's look at number 5 last. Explain why an elevation less than -5 feet represents a distance from sea level greater than 5 feet. So we want an elevation that is less than -5. So a number less than -5 could easily enough be -6. So we have -6 and -5. And we know that -5 feet from sea level is the absolute value, which is our distance from sea level. We know sea level represents 0. So -5, the absolute value of that would be 5. The absolute value of -6 would be 6. And we know that 6 is a greater number compared to 5. So it is a greater distance from sea level, which is 0, than -5 feet, which is slightly closer. Well, guys, I hope this lesson through Module 4, Lesson 3, Compare and Order Integers, has been useful for you. Have a great day.